Podemos?
Sim. Sim, tudo certo aqui.
Obrigada. Então, boa tarde a todos que estão aqui no Rio, a todos que estão em São Paulo. A gente tem mais uma apresentação do immunowebinars. So I'm going to start speaking English, and it's especially a glad moment for me to introduce Professor Cláudio Canetti, a friend from old friend. From the undergrad time of our life, Canetti, like me and a lot of other professors here at the Institute of Biophysics, Carlos Chagas Filho, are graduated in biology from State University of Rio de Janeiro. After that, Canetti did his master and PhD at USP, Ribeirão Preto, in a very important group on pharmacology, led by Professor Sérgio Ferreira. Canetti was supervised in his master and PhD by Professor Fernando Cunha. And since beginning, worked with inflammation and cells like macrophages and neutrophils and lipid mediators. And after that, he went to his postdoc period in the University of Michigan. He did a period of postdoc too at Paris, Marie Curie. Canetti is professor here in our institute since 2006. 60 years on like professor here. Since then, he is a professor. He is a researcher at the Laboratory of Inflammation. An important collaborator of our group. It's been a pleasure all these years to work with Canetti. And since then, he works with Leukotrienes. That's a molecule, a group of molecules that also are very important for me. So it's going to be a great pleasure to listen Canetti talking about Leukotrienes and his view on that. Canetti.
Good afternoon, all. Can you hear me in São Paulo? I hope so. Let's start. We are our schedule. So I think that everybody knows me here. I'm going to talk today about leukotrienes. That is my main goal of interest. Leukotrienes, and I put this title, underappreciated mediators of inflammation, because in my view, leukotrienes are underappreciated, and I don't know why. I'm here to try to convince you that this should be changed. As Cristiane told, I started my scientific career with 18 years old, doing biology grad school in UFRJ, State University of Rio de Janeiro. Then I moved to USP. I was fired in this lab, and then I moved to USP, where I did my master and doctorate with Fernando Cunha. Then after that, I did my postdoc, and in 2006, I started the professor here, and we initiated our lab in 2007. And 2 years after that, we published our first papers in the Heart of the Lab. And what's important here is that my first publication, I already talked about leukotrienes. Okay? So I'm going to give a little introduction on leukotrienes. Leukotriene is metabolized by arachidonic acid. It's part of the metabolism of arachidonic acid. It's not the best known. The best known is arachidonic acid is metabolized by cyclooxygenase. But Arachidonic acid can be metabolized by below, the key enzyme of this pathway, together with pyrolysoxygenated preventing protein that is essential for the synthesis of leukotrienes. Once it happens, you create an intermediate mediator that can be later metabolized, hydrolyzed to leukotriene B4, that is very famous for neutrophil activity and neutrophil migration activity, and or can be synthesized to sustainable leukotrienes, called like long time before they were called slow reaction substance of anaphylaxis. Okay? Just to have an idea of the size of these fields, if you compare just leukotrienes, the number of papers that you have today is close to 26,000 papers now. If we put in the PubMed prostaglandins, then we reach like 155,000 papers. And if you compare, for instance, with cytokines, then you have close to 1 million papers already published. Okay, just to figure out how small is the field of leukotrienes compared with cytokines. Does it work?
Yeah.
Okay. So a little bit more of the synthesis in action. Leukotriene. The name of leukotriene came from because they were first discovered as products of leukocytes, so part of the name leuko, and trienes due to the presence of 3 consecutive double bonds in the molecule. Any leukotriene has 3 double bonds. Once synthesized, the leukotrienes are exported by transporters, and outside the cell, in the parenchyma, it can reach the receptors in other cells or an autocrine action also is possible. So the biological actions of leukotrienes are due to their binding to the high affinity or low affinity receptors, respectively to leukotriene B4 and for sustainable leukotrienes. Okay? Then we reach the biological actions that I'm going to talk a little bit today. So in my mind, pretty much leukotrienes are everything and are everywhere. Not all at once, but in determined time points. But in my life, pretty much leukotrienes has been all over the place. So if you think about leukotriene before, specifically leukotriene before, the first idea that comes to mind is the potent chemotactic activity of this mediator. It's the most powerful chemotactic, neutrophil chemotactic mediator in your whole body. Okay? More than C5a, more than IL-8, more than any other chemokine with neutrophil chemotactic activity. And for sustainable leukotrienes, you think about asthma, mainly about asthma, okay? Because there are plenty of publications showing the activity of sustainable leukotrienes on the hypersensitivity reaction. And talking a little bit about specifically about leukotriene before and this major activity to produce to recruit neutrophils, we explore a little bit more these actions. And in the first part of my talk, I'm going to talk about leukotrienes, a crosstalk between leukotrienes and cytokines. Okay? And in my first publication, long time ago, more than 20 years ago, we were studying neutrophil recruitment to the peritoneal cavities of immunized animals that were challenged with the antigen, with albumin. And then you can see the migration happening here. If you treat the animals, the mice, with NK886, that is a flap inhibitor that inhibits the protein that helps fibrillose. Or if you block the receptor, the high affinity receptor of leukotriene before the DLT1 receptor, then you can completely block the accumulation, the neutrophil accumulation to the peritoneal sites. And in the same publication, in this first publication, we were already able to demonstrate that some cytokines here showing TNF-alpha, that the migration invoked by TNF-alpha can be blocked, pretty much almost abolished by the same treatment with the inhibition of fibrillose synthesis, demonstrating that the chemotactic action of TNF-alpha in vivo is an indirect phenomenon, okay, that depends on the release of leukotriene before. And after that, two years later, we were also able to demonstrate that leukotriene before was also involved in the migration, in the neutrophil migration induced by IL-18. In this paper, we can show here IL-18 evoked neutrophil migration, and if you block the synthesis of leukotriene before, or leukotrienes, by fibrillose inhibition, flap inhibitor, or the action of leukotriene before by the use of the antagonist, we can block the neutrophil migration induced by IL-18. IL-18, when injected, produce leukotriene before, and this leukotriene before produced by IL-18 can be blocked by the use of an antibody against TNF-alpha. Or in other words, showing that when you inject IL-18, you have the release of TNF-alpha, and maybe probably this TNF-alpha that is responsible to induce the production of leukotriene before. And here we just confirm that TNF-alpha is released upon IL-18 injection. So it was true for TNF, was true for IL-18, the dependence. We also showed for LIP1 alpha, the CCL3 ligand. If you inject LIP in the peritoneal cavity of mouse, you see neutrophil accumulation, and you can block this neutrophil accumulation using an antibody against TNF-alpha, or putting again the release of TNF-alpha with the stimulation of LIP1 alpha. If you do the injection of LIP1 alpha in wild type, you know that causes neutrophil migration, and this is blocked if you inject LIP1 alpha in TNF-alpha in TNF-alpha receptor, the receptor 1 knockout animal, showing that LIP1 alpha depends on the release and reaction of TNF-alpha. LIP1 evoked neutrophil migration that is blocked by leukotriene synthesis inhibitor, or in other words, showing that a sequence of events to, in the end, evoke the neutrophil migration to the sites. And this neutrophil migration is also dependent on leukotrienes. True for LIP1 alpha, also true for LIP2. And it's beautiful article that was published by Cláudio, that is not with us anymore, unfortunately. He used in immunized animals the same protocol that I used in the first paper. If you inject ovalbumin, then you can block the migration with an antibody against LIP2, showing another chain, another piece of this chain. This migration was blocked again by TNF, by leukotriene before synthesis inhibitor, and if you do the migration, the challenge, the antigen challenge with the LIP1 alpha knockout, you see the same reduction. And in the end, just to prove directly, if you inject LIP2, you can block the migration induced by LIP2, inhibiting the synthesis of leukotrienes with the treatment with MK886, and also with TNF-alpha. So we are pretty much with this, we put together, and we try to convince everybody that need what upon this NIP2 simulation, you have the release of NIP1 alpha that induces TNF alpha that at the end stimulates the release, the production of leukotriene before that is essential for neutrophil accumulation. Not only for those cytokines, but we also did for IL-1 beta, now in rats, not in mice. And IL-1 beta is the same. When injected, it causes neutrophil migration, and you can block once again with a leukotriene before with a leukotriene synthesis inhibitor, showing or suggesting that for IL-1 beta is the same. You need to have the production of leukotrienes. So this is a partial conclusion that several cytokines, here I put TNF-alpha, IL-1 beta, IL-18, NIP1, and NIP2, they cause neutrophil accumulation, inducing as an mediator leukotriene before. And we know by in the literature that leukotriene before, there is also a crosstalk with several other mediators and can enhance the release of those mediators, creating a positive loop to generate more and more neutrophil accumulation or activation or whatever is the biological activity that you are investigating. When I was in my postdoc in 2002, the group of Cristina Barja Fidalgo and Pedro Oliveira here in Federal University, and Cristina at the State University in Rio de Janeiro, they showed that heme, the injection of heme, can cause neutrophil accumulation, neutrophil migration. And 10 years later, when I arrived here, I was already a professor here, I convinced my doctorate student at the time, Ana Paula, to investigate if the migration evoked by the neutrophil migration evoked caused by heme injection was also dependent on leukotriene before. And we were able to demonstrate that. How? So if you inject a heme, you can see neutrophil migration, and if you inject an in-5-LO deficient animals, the migration is decreased, is inhibited. The same you can reach with a pharmacological inhibitor, inhibiting 5-LO activation by xylitol treatment. You also decrease neutrophil migration. If you use receptor antagonists, two different receptor antagonists for BLT1, the high affinity receptor for leukotriene before, also neutrophil migration is decreasing. And to prove that leukotriene is present, we measure, and we saw that after injection in the peritoneal cavity, we were able to measure good amounts, significant amounts of leukotriene before. This phenomenon was dependent on macrophages. We did a very old-fashioned way to modulate macrophage numbers. So we use it here, the injection of 2-glycolated, and 3 days later, we saw, as just to confirm now, that we have a lot of macrophages present in the cavity. And now, if you inject heme in this situation, in that moment that you have a large amounts of macrophages in the peritoneal cavity, the neutrophil migration is much, much higher than when you have regular numbers of macrophages present in the cavity, showing that if you enhance macrophages, you enhance neutrophil migrations, or in other words, saying that the response was dependent on macrophage stimulation. This was true for macrophage, but not for mast cells. We did the opposite strategy. We decreased the number of mast cells with 2 different models for 80 compound and also by water injection. If you decrease mast cells and then inject heme, no change in neutrophil migration. So suggesting that macrophages were involved
but not mast cells. And to confirm that hypothesis, we measure leukotriene B4 under these two different situations. When you have more macrophages present, you have much more leukotriene B4 being produced upon the stimulation with healing. And when we modulated mast cells, we decreased mast cells, the same amount of leukotriene B4 was recovered. So suggesting that leukotriene B4 was produced by macrophages, by resident macrophages, and then this leukotriene B4 is the final mediator to induce neutrophil migration. At that time, we start to ask if, okay, let's see other cell types that is not that leukotrienes connected, and where maybe leukotriene could be also important for the migration of these cell types. So in 2008, it was published in 2009, I think, we published this paper showing that leukotriene B4 was also able to modulate what? Gamma delta T cell recruitment. In the graphs, here you can see if you injected in vivo, in the mouse, if you inject leukotriene B4, you accumulated gamma delta T lymphocytes, or if you purified gamma delta T cells and then put in vitro migration chamber, you see the same. So leukotriene B4 can direct stimulated gamma delta T cells to migrate. And this is also happening in vivo in different situations in which gamma delta recruitment is also observed. One of these situations is when we injected LPS. LPS was already shown to induce gamma delta accumulation 1 day after the injection. And if you do the same experiment, but now using faveolal-deficient animals, the recruitment is completely blocked. Or in other words, showing that we did for several other situations, and we also showed the effects of leukotriene B4 controlling or modulating and being responsible for gamma delta recruitment. Population observed. This is from the same article. Okay. And we also studied this muscle in vitro experiments. If we took muscle cells then with leukotriene B4, you can see the migration in transwell plates, okay? And we can see polymerization of actin polymerization also of these cells treated with leukotriene B4. I pass the other, this is the same, but polymerization of gamma delta T lymphocytes, showing that you can really see the effect of leukotriene producing cytoskeleton modifications. So it's the same for smooth muscle cells. And now in the second part of this talk, I'm going to try to convince or try to demonstrate that this is a mediator important not only for leukotriene recruitment, but where you can see a very important participation of these mediators in disease, in several pathological situations, pathophysiological situations. Here in the first one, from the same paper that I showed the neutrophil migration before, here we can see if you induce collagen 2, induced arthritis that is enhanced by the injection of IL-18, if you treat these animals with leukotriene synthesis inhibitor, MK-886, you decrease a lot the erosion, the damage that you can see in the knee joints. Here is without treatment, that you can see like degradation of the cartilage tissue, pannus formation, a lot of cellular infiltration, and several of these landmarks are decreased with MK-886 treatment. Here we measure some, we put in a pathologist and ask to give a score to this, and you can see that in all situations, MK-886 promotes a better result, a protection, the tissue protection. This for arthritis, and if we took a look in the pain in the ankle joint after the injection of zymosan, that is a model of a pain model. If you treat the animals with MK-886, you can decrease the pain. So these are dose-dependent phenomena. In small dose, 1 mg, 3 mg, and 9 mg, you can see pretty much half of the pain is gone. This is, if you do the treatment some hours later, you can see some effect. You still are able to see the effect of decreasing the pain. And if you do the same experiment in 5-LO deficient animals, they showed less pain than wild-type animals. So reinforcing the idea that leukotrienes are involved in the pain behavior, pain-related behavior. Here, we just show that after the injection of zymosan in that ankle joint, we were able to recover leukotriene before from that tissue, and directly you can induce the pain behavior injecting what? Leukotriene before. Okay, so I can mimic the effect, directly injecting into the joints of the mouse leukotriene before, in a dose-dependent way. Okay, so this was true for zymosan-induced pain. This was also true the involvement of leukotriene before, when we injected antigen in immunized animals, but now into the paw of the immunized rats, now different species, not mouse anymore, that will reinforce the idea from different species. And once again, if you treat with MK-886, or if you block the action of leukotriene before, you have a nice reduction of the feeling, of the pain feeling from these animals. And once again, when we injected the antigen into the paw, we can recover leukotriene before from the paw tissue, showing that locally leukotriene before was produced. This for pain again. Now for wound healing, skin wound healing. This is a paper that I published together with Cláudio and also with Lisa in the United States. This was in Florida University, Tampa University. But the main result of this paper is this. If you do a skin lesion in wild type and compare with the 5-LO animals, 3 days after, take a look and see how the lesion is. So it's much smaller in 5-LO deficient. We can measure that, and we can see that despite the fact that the cicatrization process is very powerful in mice, we can also see an improvement with 5-LO deficient animals. Okay, showing that also a participation in skin wounds for leukotrienes. We also investigated leukotrienes, the participation of leukotrienes in sepsis. As you probably know, Cláudio is one of the people who has working very hard in sepsis models. And this was a paper that we did together in our postdoc, where we did the CLP model in wild type animals, as you can see, that a model that leads to 60% of the death of the animals. And if you do the same experiment, do the same holes in the second of 5-LO deficient animals, or in animals, wild-type animals, who which were treated with MK-886, you have full protection from the death, demonstrating once again that the involvement of leukotrienes on sepsis response. At that time, we worked and we tried to demonstrate that this will be good for Julius Saften, that the edema formation was decreased in 5-LO deficient animals. If you look direct to the peritoneal cavity, you see less Evans blues extravasation, or if you look to the kidney or to the lungs or to the brain, you can see that it has less permeability going on. Okay, this for sepsis, you have protection, and now another study related to sepsis, but the acute lung injury that we observed after CLP model, after sepsis, that is one of the major problems related to sepsis. And you can see here the big damage that you see after doing CLP in mouse. The lung become like completely inflamed. And if you do the same experiment now in 5-LO deficient animals and look how protect is the lung, pretty much came back to Sean, pretty much to a Sean situation. Here, if we measure, do a morphometry of these lung sections, you can also score this and see the protective effect of 5-LO depletion of the absence of 5-LO products on this reaction. We also studied lungs, but in a different model now is emphysema. Emphysema evoked by cigarette smoke. If you put the animals for a while to smoke, after a couple of days, the lungs start to show these big holes. That is the classical view of an emphysematosus lung. And if you do the same, exposure to the same situation, 5-LO deficient animals, they are protected. The holes are smaller. And if you measure this, the area, you can see some protection on emphysema. And so another situation in which leukotrienes could be involved. Lung and now kidney. Is a kidney a tissue where leukotrienes could also have a role, have also participation? And the answer is yes. If you do a lesion, a kidney lesion, evoked by an overload of albumin, if you put a lot of protein to the mouse, after a while the kidneys start to show some damage. And you can measure this damage. Just looking to the urine protein, you can measure the protein present in the urine, here in wild-type animals. And if you do the same protocol, like daily injections of albumin injections, daily albumin injections, you have also a protection of the protein found in the urine. The Western blots just showing a decreased amount of protein that we can see. And if you measure the lesion by LDH, some also a good parameter of lung damage, of kidney damage, you see also a nice protection in 5-LO deficient animals. Moreover, if you look to the tissue, to the kidney tissue, and look for the fibrotic process that happen, you can see here by picrocilious staining these red fibers here that is supposed to be collagen deposition. And if you do the same staining in 5-LO deficient animals, you can see there is a huge protection on the fibrotic process. We measure the fibrosis here, the collagen fibers, and you can see there is a plant protection of the kidney. So it works for lung, it works for pain, it works for kidney. What else? We also saw leukotriene before on behavior and motor dysfunction. This paper we published last year, me and Vitor and Julia Clark in brain behavior and immunity. The work was pretty much, major part was done by my master student at the time. And she showed that upon basal conditions, if you just took the animals and put in the hot rod, that is that you force the animal to walk in this apparatus, favelo deficient animals, they don't like to walk in the hot rods. Okay, and if you look for different other behaviors in these animals, we saw also some interesting behavior to bird in this model of that you leave several balls inside the cage, and you take a look and for how long the animals delay to bury these balls. So in this one, favelo animals, they showed like a compulsive behavior to bury these balls. We try to explain a little bit why these animals were showing these different behaviors. So we look at the motor and the hippocampus, and we took a look in the synapses. So two different proteins, presynaptic and postsynaptic. And we saw that favelo animals, pretty much in all situations, they have more synapses. So it leads us to argue that maybe there is a defect on synapses pods, phagocytosis. That is also very important, and we know now that is several behaviors, like psychotic behaviors, came from this lack of phagocytosis synapses. And here, yes, here we can see that favelo deficient animals, they have more receptor for fractalkine, that is a mediator responsible to eliminate these synapses. And if you look to the receptor to the ligands, you see less ligands being produced. So it seems that favelo knockout animals, they produced less ligands, and somehow the body tends to compensate this, creating more receptors. Okay, but we don't know. This is just a speculation. But we finished that article arguing that maybe there is a defect on phagocytosis, on the synaptic pods phagocytosis. Leukotrienes are important for infection disease, mainly tropical disease, that is a major interest here in Brazil, to study. So we did a study with João Santana, also in Ribeirão Preto, with the cruise infection, Chagas disease. And if you take a look here in this first graph, knockout animals, they have favelo knockout animals have much more parasites than wild type animals. Okay, this is kind of weird, but when we took a look into the survival rates of these animals, wild type animals, they died with 30 days after post-infection, while only parts of the knockout animals, they died. So they have more parasites, but they die, they are protected from death. We took a look direct to the heart tissue, and we can see this wild type, and this is knockout, 15 and 20 days post-infection. You can see that the inflammation is attenuated in favelo knockout mice. So you have less inflammatory infiltration, less edema, and we measure a couple of things here, but we can just put numbers to this photomicrography. And similar to what happened in the kidney, if we look at for the fibrotic process that happened in the heart of T. cruise infected animals, T. cruise infected mice, this polarized light only, but this is the picrocereus once again, this to stain collagen deposition. Knockout animals, 5-LO knockout animals has much less deposition, collagen deposition in the tissue, showing once again that the protection of the tissue by the absence of 5-LO products. Also, talking about tropical disease, leishmaniosis, we did a nice work together with Professor Robson Coutinho here. That is he studies a lot purinergic system, and we decided to take a look in the crosstalk between lipid mediators and purinergic system. And in this first paper that was published in 2014, we showed that after if you put ATP to macrophages produce leukotriene B4. Okay, and this production of leukotriene B4 is smaller if you took macrophages from infected animals, or if you infected them in vitro. And furthermore, if you do the experimentation, if you infect macrophages obtained from P2X7 knockout animals, or in other words, that do not express the receptor for ATP, one of the major receptors for ATP, you cannot see production of leukotriene B4, showing once again that leukotriene B4 is produced upon stimulation now with ATP. If you treat it, it's already known that if you grab macrophages, infected them, and treated with ATP, exogenous ATP, you decrease the amount of parasites inside this macrophage. But if you do the same experiment, now taking macrophages from 5-LO deficient animals, you cannot see the effect, the improvement effect on killing observed by ATP. So pretty much showing that ATP depends on leukotriene formation. And this was also observed with the pharmacological inhibition of 5-LO. Okay, so in the sequence of these studies, also studying leishmania infection, we observed the same for UTP. So another important purinergic mediator, ATP and UTP, does exactly the same. So both are depending on leukotriene before production by macrophages. Okay, it's the same, exactly the same situation, and we saw the same effect of leukotrienes. And now, in this last piece of data, now this was more recently, this, if I'm not wrong, was 2018. We took macrophages from different knockout animals to study what? The participation of the inflammasome in the process. Okay? If we took macrophages from wild type and then you treated with ATP, as I showed before, you decrease the amount of parasites. So you enhance the killing activity. If you do the same experiment, you stimulate macrophages with ATP, but macrophages that do not have NLRP3 or ASC or caspase 1 and 11, or from macrophages from IL-1 receptor knockouts, in any of these situations, ATP is able to exert the killing activity. So pretty much demonstrating that the activity, the killing activity, leishmaniose killing activity evoked by ATP depends on inflammasome. And we did the same, exactly the same question, but now instead of using ATP, using leukotriene B4. And we knew before that if you treated macrophages with leukotriene before, you enhance the killing activity. If you do the same, leukotriene before treated macrophages that were obtained from an LRP3, ASK knockout, caspase 1 and 11, or IL-1 receptor knockout, leukotriene before is now unable to exert the killing activity. Or in other words, saying that leukotriene before somehow depends on inflammasome complex formation. We were trying to discriminate it from caspase 1 and caspase 11. Each one was involved, and we were able to use knockout cells from caspase only, not from the double knockout, but the single caspase 11 knockouts. And we also were able to observe that in that situation, ATP was unable to evoke it. So suggesting that depends on caspase 11. If you do selective inhibition of caspase 11, you can see also the lack of activity evoked by ATP. And the same approach, exactly the same approach, how things are made, no? We observed for leukotriene before the same effect. If you took macrophages from caspase 11 knockout, the single knockout caspase, also leukotriene before is unable to evoke some killing activity. And the pharmacological inhibition is the same result. So suggesting that both ATP and leukotriene before were using inflammasome to contribute for the killing activity, for leishmanicide activity observed. This is a piece of data that we submitted. We are working on that. If you treated now in vivo, how interesting things can be, and how lucky we were. If you do the lesion, if you infected mouse for injection with the leishmania, then you just take a look of the size of the lesion. Here you will see Leishmania amazonensis, okay? And now if you do the same experiment, infected the pus with Leishmania amazonensis, but now after 5 days, I think, I can't remember exactly, you start to inject it directly into the pore. What? Leukotriene, cysteine, leukotriene D4. And then what you can observe? A decrease in the size of the lesion. So speculating that the presence of leukotrienes can be beneficial for parasite control. We saw a decrease in number of parasites when we treated in vivo, and also that ATP was able to release cysteine leukotrienes. But just another piece of in this puzzle, okay? Last year, we were also able to demonstrate that in COVID-19, also leukotrienes were involved. This paper was published by Amanda and Cláudio last year, together with Cláudio here. We took a look in several different mediators, but here in the bottom parts, we can see PGE2, cysteine leukotriene, and leukotriene B4. All three mediators, arachidonic acid-derived mediators, were enhanced in COVID-19 patients, from the plasma obtained from very severe COVID-19 patients. We try to speculate if there are some difference among patients who were discharged and who were deceased. And we saw for leukotriene before that high amounts of leukotriene before, as well as cysteine leukotrienes, were found in the group of patients that were deceased. Okay, so we saw some enhancement on leukotrienes also in the groups of COVID-19, but not as big as in patients who were deceased. And then if I have more 3 minutes, am I allowed? Okay. I'm gonna just put some very preliminary data that I have I obtained in the past few months, in which I have 2 main goals. Okay, 2 main focus. The first one, I'm very curious about macrophages and how they behave if I took macrophages from different environments. For instance, if I compare macrophages obtained from bronchoalveolar lavage, obtained after ball lavage, and macrophages that I obtained from peritoneal lavage. So in these situations, I have what? A peritoneal macrophage that is pretty much in a situation that is a sterile environment, that if you are okay, your peritoneal cavity is completely clean of bugs. And if you compare with your lung compartment, that you have like a huge area of contact with our environment, you are being challenged. Every hour you are being challenged. Every time that you breathe, you are being challenged with dust, particulate material, bugs, virus, whatever you think you are breathing. So it's, to me, became very curious to understand how lung macrophages, alveolar macrophages behavior, because they are pretty much outside of our body in the alveolar space, but they cannot inflame it all the time. Otherwise, we will not breathe and we will die. So there is a kind of balance between tolerance and to be ready to be able to fight against a pathological microorganism. So pretty much what we did, we took different macrophages from alveolar macrophages and peritoneal macrophages and compared them in the expression or some actions. Here in the first graph, this preliminary, okay, in blue alveolar macrophages, in red peritoneal macrophages. At basal conditions, alveolar macrophages, they produce less NO and less reactive oxygen species. If you stimulate those cells with LPS for NO production, they start to make more nitric oxides, but once again, alveolar macrophages, they produce less nitric oxides and less reactive oxygen species compared to peritoneal macrophages. Another piece of data, if we look for the expression of hemioxygenase here, hemioxygenase expression in alveolar macrophages and in peritoneal macrophages, how different they are. And if we quantified this PCR to confirm that, and this is just the measurement of the Western blot, the bands obtained in the Western blot. But there is no need. We can see very clearly that they are very different. Another piece of evidence, if we took alveolar macrophages and look now for the expression of the cannabinoid system, CB1 and CB2 receptors, alveolar macrophages, pretty much we were unable, or just few. You can see that the blot's not good, it's preliminary, okay? Peritoneal macrophage seems to have a lot of CB1, while alveolar does not. And the opposite way, CB2 expression seems to be observed in alveolar macrophages, but not, or much less, now we can see a band here, but much less amount compared to alveolar macrophages. Okay, this is one of the pieces of evidence. And then the another one that is also, that I'm also interested. we knew before that neutrophil migration induced by hemia is the paper that I showed before, is dependent on leukotriene before production. There are several models of kidney injury where the depletion or the inhibition of 5-LO cause the protection of the tissue, the kidney tissue. So I was, at that time, I wonder if a kidney lesion evoked by a process called rhabdomyolysis, where depending on the different ways can induce the rhabdomyolysis. But in all the ways, you have the lesion of this muscle, the skeletal muscle cells, with a huge release of the contents, the cytoplasmatic contents. And if you think about muscle, skeletal muscle, you will think about myoglobin, that is an M protein, that is full of M. So at that time, I said, oh, let's do a model in which we're going to induce the lesion, the kidney injury, by the rhabdomyolysis, by a huge lesion of the muscle, and see if 5-LO is protected in this. So our hypothesis was that 5-LO depletion is protected if I induced the lesion of the kidney by rhabdomyolysis. And I was completely wrong, because my hypothesis come out to be the opposite way. If you look, this red line here is showing that if you injected glycerol, that is the model of intramuscular injection of glycerol in wild-type animals, they survive, at least with this dose. But when we did the same injection in 5-LO knockout animals, they start to die. So instead to be protective, it seems that this is the slides, the histology of the tank. Here, wild type, when you do a regular wild type here, and 5-LO knockout, challenge with PBS, no damage at all. Some reasonable damage observed in wild type animals, as that is expected, but the lesion, the tissue lesion, seems to be higher in 5-LO deficient mice, or somehow it seems that 5-LO products are protected to the lesion. When we remove these products, the lesion becomes much higher. So this is the point where we are now, and where I am trying to investigate these two major possibilities. Okay, and just this, I promise this is the last. Here, so I did this presentation pretty much in order to convince you that leukotrienes has a broad range of effects that not turns to be only on neutrophils, but it affects several other cell types, and this can have huge impact on several clinical situations that we know. I can talk about arthritis, infectious diseases, acute kidney, acute lung injury, autoimmune disease that I didn't talk here, pain, behavior disorders, healing, and several other processes in which leukotrienes are still to be proved to performance. So all this work was not done by these people, but I remember just that, but a lot of students were involved, and they are really the major part of this whole thing. But I need to acknowledge Cláudia, I need to acknowledge Cristiane, Bruno, Robson Coutinho, Fernando Cunha, Mark Pires Golden, Carmen Penido, Celso Caruso, Vitor Rezende, Marcelo Bosa, Taquia, João, Cristina, João Moraes, and all the financial support received. So thank you very much for your time, and I hope not to upset you too much. Thank you.
Thank you very much, Canetti. Beautiful presentation, an overview of your life.
My life.
It's your life. Thank you. So we are going to open for questions, and as traditionally, I'm going to open first for students. So now I'm going to ask Mateus, but Mateus, you can do in two different ways. You can come here to speak. So you can tell us what we are going to ask, and I can reproduce here.
So, thank you for the presentation. It was wonderful. My name is Matthews. I'm a master degree student, and I was wondering about Lithuania. Lithuania is Leukotrienes is Leukotrienes have low migrations of neutral migration, and the result which shows the lower the decrease of the national size maybe came up to me in the question is could be the decrease in the size related to less neutral migration. Besides in Lithuania, the neutral migration is the first part of the pathology disease, and came to macrophage migration. So maybe the Leukotrienes have to play a role in this situation.
Absolutely. Very, very nice question.
Canetti, repete a questão.
Okay, I'm going to try to.
Yes.
Our friend here is asking if neutrophils or other cells on the pretty much on the
Now? Yes. Okay, he is asking if the lesion represents, what exactly is the lesion? We don't know. You can have like different ways to evoke the lesion. The lesion is due to the cellular infiltration, is due to oedema formation, and is due also to the presence of parasites in there. And sometimes you have a dissociation of the lesion and parasites. That is also important to be noticed. So, but it's a good way to at least to have an idea if the treatment is going, it's okay or not. So it's really hard to in the end, like in very end, it's very hard to determine exactly why the lesion is lower. We just took a look at the number of parasites and we saw less, but we don't know if this is the reason. Could be the leaking, could be just because we removed a factor that is also known to create a permeability, vascular permeability, and when we remove that, we impair several things that could happen after the leaking. Okay. It's in the cell.
Oh, they're down there. There. Estava perto do teu ouvido.
So my question is about the paper.
Oh, disconnected. Oh, disconnected. Anderson can't hear. Can you hear now, Anderson?
I can hear you, but not the students or the audience.
Okay.
Okay, so my question is about your work with the CX3CL1. I'm very curious, yeah, because you saw, so it's known that fractalkine is also membrane bound on neurons, and that's what's important for synaptic pruning. And you saw that the receptor is increased in microglia in the 5-level knockout, but you have a decrease in fractalkine overall. So I'm wondering whether you think that it's probably a 5-level product that has a direct effect on neurons that makes them express less fractalkine, or whether it's an indirect effect that makes microglia express more of the receptor. How do you think this relationship works?
Okay, thank you for the question. It's once again, it's impossible question to be answered. Like, at least now that we don't know, the main answer will be I don't know. But with this phenomenon where you see less ligand, more receptor is well known several biological response. For me, it's a way to compensate the lack of the ligands. So you have to enhance the receptor. We don't know if this is what time during the genesis of the animals, the embryological life of this animal, it happens. We try to mimic the same effects, at least in the Rota-Rod behavior, the motor behavior, using the pharmacological inhibitor, and we were unable to see that. So it seems that it's something that's prior life, or maybe prior born delivery. We don't know if it's something that happens in the childhood or later, but we don't know. We need to investigate to better.
Do you know if the other glial cells, like oligodendrocytes and astrocytes, are normal in the knockout, or if maybe your effect is due to impaired generation of these other cells instead of just neurons?
There are no data that I know showing some different from wild type and knockouts in these cells. We already performed some experiments long time ago with dendritic cells, but on phagocytosis, and we saw some effect of 5-LO on that, but does not answer your points. But nobody has studied that.
Thanks.
Third student, Lucas. Pergunta daí. Canetti repete.
So in the first slide, you showed that when you did a lesion scheme model in mice, the 5-LO cow mice had better tissue there and fragmentation. But then on other slides, you showed the leukotrienes had that when you administered the leukotrienes to mice that had been infected with Leishmania, they had better prognosis.
Right.
So how do you think is the difference in the phenotype about the tissue there on the skin in this whole case?
Okay. He is asking if I can explain the difference that we found in the phenotype observed with our skin lesion model, compared to the parasite infection by leishmaniasis.
Posso comentar? So, and also I think controversy may too strong, but the fibrosis data, the deposition of collagen in I think in other models, several models that you show that yes, that it's decreasing.
Decreasing 5-LO.
Yeah, so that appears to be on the other way around from the healing data.
The Chagas model can be
interpreted by different ways. Yeah, right.
In the lung.
Yeah, for me, leukotrienes and prostaglandins and pretty much all the lipid mediators that I have been working with, there are always at least two sides of effects. One that is, say, oh, this is a beneficial effect and this is not a beneficial effect. So we pretty much took this idea all the time. Okay, but this is not will be useful. If it causes pain, how can I use something that causes pain? But in the other hand, like if you treat it with with a cream, they don't feel that much. So you need to figure out the beneficial effects of the removal or the replacement will be like can turn this into maybe an approach that can be used to treat something. Okay, but this is not my main point. My main point is just to determine what is going on and if they are improved or not, for bad or for good. Okay.
And now, if we don't have another student, we are Anderson is with his hand. Do you want to ask? You can.
Okay, thank you. Is there any other student that wants to make question? Otherwise,
there are more students. No.
No, you can go ahead.
Okay, Canetti, good to see you after so many years. Sorry that I wasn't here in the very beginning. I got a little late, but I have one comment and two questions that are related about the first part of your presentations in the neutrophil models, the migration. Some of the models you employed, when you block leukotrienes, either by pharmacological approach or using the knockout mice, some of the migration is totally blocked, but in some other models, the migration is just partially blocked, right? Especially heme, for example, the heme model was partially blocked. So my questions are, did you guys check in this residual neutrophil migration, which are the chemoattractants involved in this residual migration? And second, thinking about like the many chemoattractants that bring neutrophils to the sites, do you envision any hierarchy, like which one should come first in order to the neutrophil migration be like really strong and really complete in these situations?
Okay, Anderson, thank you for your question. You are completely right. We have some situations in which leukotriene leukotriene B4 seems to be the major mediator responsible for neutrophil migration, and in some others seems to be like a relevant one, but not fully the only one. Yeah? And we never took a look on this residual neutrophil chemoattractant factors that are responsible for this residual neutrophil infiltration. We don't know, and to be honest, like I can just think about the classical chemoattractants like C5A and some chemokines, and when we took the idea of chemokines into the mouse fields, then you have a problem, because you have many molecules that are homologous of IL-18 IL-8, for instance. So it's quite difficult. It's easier to be done like in human cells. That then you use an antibody against IL-8, and then you have an answer. But for mouse, they have like at least N78, GROW, MIP1, MIP2. So you have several possibilities. And when we just took a look on these few chemokines, bar cytokines, but this is still to be demonstrated.
Thank you.
I don't know if okay.
No, yeah, my comment was more based on the because in some models, clearly the inhibition of leukotrienes is beneficial, and in other models is not quite the same, as you mentioned. And I was wondering whether like this residual neutrophil can make a difference in the phenotype, right? Like, because it's different if you block 100%, or if you block 50%. So
I cannot rule out the possibility of other mediators. I'm just trying to say that leukotriene is one of these major chemotactic mediators that are responsible for this neutrophil accumulation observed in several models. It's just that. I cannot talk more because I do not have data to support.
Okay, thank you, Anderson. So move on to Professor Júlio Schaften.
Canetti was very nice to have the opportunity
No, the healing is faster. It's faster. Right. It's not protective. Right.
The issue that I really would like to see each of these leukotrienes, whether they are the same or different, how they are regulated when they are secreted. The second point is related to the desensitization of each of these receptors, because in many systems, when you have high levels of ligand, you have desensitization. Right? What are the rules of the games in the leukotriene system? Because this is something that sometimes helps you to understand the fine regulation of the process. And because you have to go from inflammation to healing, to remodeling. Then you have the issue of protein cells, which you raise, right? And everything is happening all together.
It's so, like them all together.
The dynamics, we need some basic information about how the receptors are regulated and how the ligands, are regulated also.
Yeah.
They may be destroyed easily, or maybe they are stable. I don't know anything about this.
Canetti, repete a primeira e o segundo.
Júlio Schaften is arguing that the receptors and the half-life of the leukotrienes are important for their, of course, for their biological activities. And I do agree with this. There are some information about receptors expression, but they do not seem to be overexpression or downregulated with few hits of the agonists. And the agonist does not seem to live for a while. We are talking about few minutes, no more than that. So we don't know if the production is happening kind of bursts, not continuously, because when we measure in a single time point. And what we know is that it happens very fast. So we are not talking about hours, like we're talking about cytokines that usually you took 2 hours, 3 hours to start to see the protein, the synthesis of the proteins. When we're talking about lipid mediators, we are talking about 1 minute, seconds. So after the stimulus. So it's very, very fast. And the sensibilization process involved in this phenomenon is not like the one that has already been described, for instance, for IL-8, that it had phosphorylation and those tools of the GRK are involved. No, there is pretty much, we don't have that information regarding BLT receptors or cysteamine receptors. but the idea comes that you bring more receptors when you bring more cells carrying these receptors to the tissue, pretty much. Right. Yeah, if it's something sharp that happens very single point and does not stays for a while, then you can have this.
That is not necessarily
At least for cytokines, we believe that it happens. For activation and migration, it seems to be at least, and in biology, this is something that is important to be listened mainly by the students. It's very often when we work with neutrophil migration or any other biological activity, if you remove one of the factors, everything collapses. So it's not new, the idea that, or at least to show that the leukotrienes, when we remove leukotrienes, that everything falls apart. Exactly. So it's hard to determine if it's a sequence of events or if it's how it works for sure. So we took like these first years in neutrophil migration, just trying to figure out what is a possible sequence that could exist for in allergic or in ovalbumin immunized animals, or in something that does not need the immunization like zymosan, or a direct insult like LPS. Okay. It is. It's a huge crosstalk.
Yeah. And Lucas has another question for you.
No, I don't deserve this.
No, I think Lucas, because of the time and because of the students and people in the room, I'm going to finish today. Webinar. Thanking again, Canetti, very much. You need to go to the chat because a lot of people is congratulating you and saying that was great.
Thank you all. Everybody is very polite.
And next week we have same room, same everything here. I don't remember the name of the speaker right now, but we are going to let everybody.
Finish the talk with the big fish.
Yes, we missed the fish.
I'm small fish is on.
Thank you, everybody.
Thank you, everybody, for your time.